for another video, and this one's going to be a bit of a quickie today. I'm going to start with the doorbell kit and we're going to do some modifications on it. Why is this the case? Well, we've had the museum that I work for, or that I volunteer at, we've had some problems with people sneaking into glass cabinets without permission, and so we need to take a stop to that, or at least put a stop to it is the word I'm after. Scripting, it needs to be done. So the idea here is we're going to take a magnetic reed switch and put it inside this receiver, and we'll stick a magnet to the glass door, and we'll hide a couple of these in the museum somewhere. We might do a couple of mods to one of these receivers to make it look a little bit more offensive and flash and make a really loud noise. I'm not sure how I'll achieve that, but I'll get that open and we'll do something like that. So let's get our parts sorted out. Right, I've got everything laid out. Now, first thing I had to do to get this open, I needed to get to this screw, which is a bit unusual. Most of these just have two latches on the back, and I tried a bit to get that open. But I'm going to remove the battery isolation tab to start with, and we're going to just see if everything functions first. I know I'm not mixing batteries, and these are new. These are just the last out of two different branded packets that I've got. Let's try and see if we get a function here. Right, so they work. Alright, so that we can put aside for the moment, and I might put the battery covers on just so I don't lose them. Okay, do that. I'll get this open. We'll see if we can get some access to it, because I'll need to do some modifications. I'll get my spudger here. Right. There's our circuit. Oh, and it uses a 2R32. That's nice. That's a nice simple design instead of using those 12-volt batteries. What are the A23s? I bought a whole bunch of them a little while ago to make a 72-volt radio battery. Undoing screws, it's riveting videos, isn't it? Now, I should be able to peel this circuit out. We're going to need to get to it. So give me a couple moments and I'll pop this out. We have the circuit out, and it might look a little scary and complicated, but really all we need to do is actually quite simple. So we'll grab some components out of here. These are magnetic reed switches. I'll put one under the microscope in a minute and show you how they work. But basically there's two reeds in here with magnetized tips. When you put them close to a magnet, the reeds stick together and they form an electrical contact. The idea here is we're going to solder one. Let's find a pointer here. We're going to take this little tactile switch here, and we're going to take across two of these contacts, and we're going to connect one of these switches and position it sideways in the cavity here to act as a magnet sensor. And that should be pretty well the extent of the mod, but let's get the microscope out so you can see a reed switch working. Okay, we've got the microscope out. I'm going to take a couple of blobs of blue tack here, and we'll position this in front of the microscope, and once we do that we'll turn the microscope on. So I'm going to turn our lights on here. Okay, we'll change our angle slightly. Now you'll hear a slight little click in a moment when we start the record. So here we go, 3, 2, 1, click. That helps me synchronize it. Now let's do some focus here. Now I wonder if we can see the reeds in here. Let's move them over a little bit. So now I need a nice little pointer. This might not work as well, but we'll see here, this little gap right here in between. You see there's a little gap right in there where those reeds are. If I take this magnet over here, this is out of a Swan camera. We put the magnet near it, you see them getting close and they're touching. So we'll go click, 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 click. And what we might even do is I'll hook in a continuity beaker. I have one over in the back here. We'll hook up to this, and we have some little clip-on terminals here that might clip on, hopefully without disturbing it too much. Okay, now as we move a magnet near this, we move our magnet down a little bit. We'll go right near it. We'll go as we put our magnet in the right orientation. This is a very strong magnet, so it picks it up from a distance away. If I choose a slightly smaller magnet like this one, we need to get closer. Where are we? These are much smaller. And we've got to get the orientation and polarity right. They might not actually be magnets, they might be just bits of steel I have up here. Here we go, I've got a little baby magnet. Covered in blue tack, but here we go, let's try this guy. This guy was actually used for triggering reed switches. I wonder, let's try the big one. Okay, these ones obviously need slightly more Gauss to trigger them. So I'll have to remember that. Okay, anyway, experiment completed. Let's turn microscope off and let's get on with the modification. Now the next step I'm going to go through, just so that I don't get things wrong and in the sake of doing this properly, I'm going to just reposition this back in here temporarily, or into the front half of the cabinet, the way that we would expect to see it in situ, and then work out the orientation. So we need to put this in the right hand end of a cabinet on this wall, so the door will be sliding in front of us. If we imagine this will be sitting here, so we want the reed switch on that side. So now if I remember that, I'll mark it with a Sharpie. If I can find the Sharpie. I'm sure there's one in here. I'll have to pause and find it. And I found the fabled Sharpie. So we want our reed switch on that side. It's just a black line. All we need. So now we can take this out and work on it. While I'm working on it, I'm going to take the liberty of popping the battery out and probably getting permanent marker on my finger in the process. Alright, that just prevents crazy accidents. No, I didn't get any on my finger. Now, because I lost my big blob of blue tack in the last job, I'm going to use some contaminated stuff. I don't think I'm going to go to too much effort here. I think I'm just simply going to hot glue this on. And as I don't have a hot glue gun, because I think they're crap, I'm going to use Mr. Stoner Torch Red, because my wife's nicked off for the blue one for lighting candles. And we're going to heat the glue stick up, and I need some ventilation. So let's bring some ventilation over here. External fan, and let's get some hot glue heated up. And of course I have other fans running in this room at the moment, so the ventilation system's not quite working as desired. We'll get a bit of hot glue going here, and before it sets we're going to position reed switch right here, and hopefully in the right orientation. That way should be fine. Yes, I think that's the correct orientation. I will test it shortly when the glue cools off a little bit. And then once I've got it right, I'll trim the leads and we'll put some patch leads on it. The glue has cooled sufficiently. I'm going to attach these two probes to it and see if the magnet will trigger it. Well, okay, that's from a miles away. We need a smaller magnet. And I'm tipping stuff over in the background here. Right, so let's take a smaller magnet, which is on a screwdriver. Yep, that will work from a closer distance. That works, needs to take very close up, so let's try that orientation. It needs to be a bit higher up. Yep, okay, that works. Alright, so I'll have to be just, I think I'll test position my magnet first when I put this on the wall. Okay, so that's going to work from a suitable distance. Yep. Now, you might ask at this point why I'm doing this, so, or rather how I'm doing this. Let's cut this and I will cut some more explanation in a minute. Now, you might ask at this point, I'm doing this, and this is a normally closed circuit designed on a normally open system. Well, the idea is that the magnet won't be resting next to this all the time, but that you won't be able to open the glass cabinet without a magnet passing past it. I'm going to put a magnet slightly forward of it and slightly behind it on the glass panel, so either way you go, it's still going to trip the doorbells. And on top of that, I'm going to pick the longest, most annoying, loudest piece of music that these doorbells can do. So once triggered, it only has to be triggered very, very briefly for it to trigger a prolonged noise and thus ensuing embarrassment. So let's get this all happening. I'm going to change our camera angle slightly. Now I'm working through the viewfinder, so this could be interesting. Taking my flush cutters here just to trim a bit of lead off here, just so that we fit back in the case. Now we're going to get a soldering iron hot and tin these ends. Okay, I've got my ventilation moved and I've got some heat on the soldering iron, so let's get this done. Trip these on and we will tin that one. Now we need to find a little bit of link wire to do the job. Okay, so I found a wire of 30 gauge, or a roll of 30 gauge wire, which has just unraveled on me. I always want to hit the record button. I'll try and stabilize this end as best I can here. Right, now this is uncoated wire. Normally I would use enameled copper like this, but pretty sure this stuff is uncoated or not enameled. Got a bit of real estate problem going on up here. Let's get this one soldered. Hello, solder. Come here just on the top of the screen, just out of view. Now we've got our ends tinned. Get a little bit of flux going here, and we'll just tack this on the end. I'm going to do one end at a time, and you'll see why in a moment. Right, that was some hot fingers there for a minute. Let's neaten up some cables that are off screen and continue. So now that we've got our wire on, we'll notice a couple of things about this board. There is a switch number 2 position here, and I think that's obviously for changing modes and whatnot. So you'll see here, this one is a ground terminal and this one goes off to another bit on the IC. We don't care about that. What we do care about is this ground one that gives me a path that I can run this wire to. So I'm going to start off by grabbing the end of this wire in the tweezers, because I'm a little shaky right now, and running to that outside ground right there. And we'll see why I've chosen to do this in the order that I am fairly shortly. Sounds like I have email. Right, and we want to take a route that avoids that screw hole there, and we'll go back down through that. So now we'll flip this over and put some solder on that. That'll give us one of our switch connections right there. Right, and we will hit that with some flush cutters. Right, now I need to find a way to get this through this hole that doesn't make contact with that. So give me a moment to think about this. Now I'm holding this very precariously, and this might not be an ideal way to join these two, but I'll get these all in like that. Cool. Slightly messier than I would have liked, and there's a big fat magnet over the side here that's got hold of my tweezers just suddenly. Let's move that out of the way. Okay, so now I'm hoping if I get this through here at the right angle, doesn't make sufficient contact with that, although I could probably find a little teensy tiny bit of insulation in there. What I think I might do is position it so it's not making contact and put a tiny little blob of hot glue in there. In the meantime, I need to jump this over a bunch of things. This is where enameled wire would have been really nice, but alas, I can't find any. So I'm going to do a bit of a trim here. I'm going to adjust my camera angle up slightly so that you guys can see what I'm doing a little bit better. Magnet got my tweezers again. So leaving myself a little bit of room to hook this up over the top of the existing components in here. And hopefully, if I can do this three-handed job, I want to put a little bit of, I want to tin this here. Oop. Okay, well the contact works and the switch is open. I've shorted something. Alright, time to pull the battery. Okay, so I've got that bit in there. Now we'll probably try digital zoom in a minute, but let's go in like this. This could look horrible, but you can see here, if I get my screwdriver out, this little hole here, I've got it not touching the outside there, and I've bridged it over. There's a little bead of solder on there. What happened just before is a little drop of solder dropped in between the LED and this component here, which of course trips it to transmit. The other factor with these is they transmit a set number of cycles for a few seconds first, which is very nice. It's actually kind of handy as an alarm. It means that even the tiniest trip means that it's going to reliably set the doorbells off. So let's see if we can pass this past a magnet, and we'll get off this horrible digital zoom. So we will insert battery and we will pass it past a magnet. Let's this thing is grabbing. Oh, that's worked. I held the two in the one hand. So I'll put my magnet here and wave past here. Okay, it works. Rightio. Alright, it's reassembly time, and adjust the camera angle time. So I decided not to put a bit of hot glue on here. I figure it'll sit in place suitably once it's reassembled, and it's probably not going to get touched for some time. Now, I think that's the way this goes in, and I think there's a little locating lug in here somewhere. Or it might be just the screws that hold it in. We'll get this in and we'll be right back. So all this excessive doorbell chiming has attracted the attentions of a local apprentice. Yep, a local apprentice has found me. So now we've got the covers on, let's see if this works. I've forgotten which side the doorbell is actually on. Oh, the big magnet sucked up the little ones. Let's try that side. And probably not on this side. Cool. Okay, so that is my side. I better mark that before I forget.
I got a Kinder Surprise.
My apprentice has found a Kinder Surprise apparently too. Alright, we will be back in a moment once we crush and consume the contents of that. The last thing we need to do is to apply the double-sided sticky crap.
Oh, so sticky.
It is very sticky.
It's very hard and sticky.
This is what happens when you attract a wild roaming apprentice. They give you running commentary on everything you do.
Yes, looks like a hole bit, like a ticket.
Punch a hole out like a ticket, you say?
Yeah.
Okay, now we need to get this sticky pad off, hopefully with these tweezers that have got no grip. And it's getting to the end of the day, so of course multiple sclerosis means that I have very little dexterity left. Here we go. Drop this over the locating holes very nicely. Alright, that is ready to apply. Now obviously I'm not going to show where these actually go in situ because it's a security thing, but I'll see if I can come up with a demonstration. Alright, I've got a temporary setup on a sliding door. Now in the actual scenario this would be glass and then be a magnet here as well as this one, so either direction that you move this sliding door it's going to get tripped. But if we just quickly whip this nearby, it's going to continue to go off. And if they slide it just a little bit, it's going to keep pushing that bell continuously. I think that'll work just nicely. Okay, now there only remains one other task to do for this, is to pick the most annoying ringtone, or doorbell tone, or door chime, whichever. But for the sake of my sanity, I'm going to pull the batteries out of one of these while I do this bit. See what different tones we have. The good old classics. Good old Beethoven. That's a decently long one. No, not good enough. Well, that's loud. I think that one's suitably loud enough. What else have we got? There's a few annoying ones in this. Apparently there's 36 of them. Oh, that one's annoying. Oh, God, no. Oh, yeah, okay, you couldn't ignore that. And it's a good long one, too. You're going to know you've done something you shouldn't with that. Oh, no. The tones. Oh, God. Ow, that hurt my ears. That was loud. Is there a volume control on this? I don't know. What do you think, guys? Maybe we should put a brighter flashing light on that. Oh, that's like something I heard in church as a kid. Oh, I think it's half the reason I don't go back there. What that's meant to be, but that's horrible. Oh, so is that. Alright, safest to say there's a lot. Oh, okay, shut up. Okay. Oh, relief. Okay. Well, I think we've proven a point. These would be suitably annoying, and we've got any number of options for them. Actually, it doesn't matter. I wonder if they both play the same thing now. Really? But I just changed them all. Okay, let's see what happens now. Okay. They can play two different chimes. Okay, let's try again. I'll wait till that's finished, and then I'll see if they play a different chime. That could be an interesting feature that I can exploit. Okay, stop with the Beethoven. Now let's try. Let's push a button. There is a slight delay, which is nice. That means they won't be entirely sure what's tripped it. But either way, it's going to alert everybody to what's going on. All right. So, I was thinking about making these lights brighter, but they're actually quite bright. The camera doesn't really do them justice. But it's certainly going to call a lot of attention to itself. And we've got two of these. We can place one in close proximity to the system and another one off in the admin office, so we'll know immediately that somebody has opened a cabinet that shouldn't, which will be nice. And this system won't flatten the battery if the magnet's not parked right next to the sensor all the time. So, I think we're done. Anyway, this has been a quickie one. Hopefully we'll do something more in depth soon, and I can tell you I do have a few things coming up. So, see you all next time.